Okay, so in this video we're going to be learning a couple things about absolute value. Absolute value, you should remember some of the main ideas of absolute value from what you've learned in the past. Like these straight bars, we call these the absolute value symbols. And what those do is if we have a number inside of there is that what we're looking for in this case is the distance that number is from 0. So the absolute value of -2 is what distance is that value from 0? Well, it would be 2 units from 0. Or if we have the absolute value of a +3, well, that's not going to be a negative number because our distance is measured in positives. So the absolute value of a +3 is going to be a +3. So in other words, the absolute value of any number is going to be a positive value. So using that concept, let's look at this first example here. This first example is going to be a very simple concept, but yet if you can understand and grasp what this concept is referring to, it's going to make it easier to understand the rest of these equations. So ask yourself, what number and what numbers can I put inside of this absolute value that would give me 2 as my answer? Well, you could put 2 in there, and that would give you the absolute value of 2 would give you 2. Or you could put -2 in there inside the absolute value, because the absolute value of -2 would also be 2. So in other words, the value there of x could equal 2, or x could equal -2. So there's 2 separate answers that we could have there, 2 or -2. So let's apply that now over here with this 12. Now imagine that I don't know what this is right now. Let's see. Okay, so I want to figure out what 2 items can I put in here that would give me 12. Well, I could put 12 in there, or I could put -12, because the absolute value of 12 would be 12, and the absolute value of -12 would be 12. Well, we know that it's not just x that's inside of here, it's x plus 3. So that value, x plus 3, could equal 12, or x plus 3 could equal -12. And again, the reason why we're getting that is because we're looking at what numbers can we put in here that would give me 12 as my answer. I could put 12 or -12. So that means that these 2 values, the x plus 3 could equal 12, or that x plus 3 could equal -12. So we're always going to end up with 2 equations that we need to solve. And it's not always going to end up like this, where we end up with 2 of the same numbers, where we're going to end up with 2 of the same numbers, just opposite signs. That's not always going to be the case. Every once in a while that'll happen, but most of the time it'll be like this one, where we get 2 completely different answers. So to find the answer, we subtract 3 here. 12 minus 3 is 9. To get the answer over here, we subtract 3, and -12 minus 3 is -15. And you can always check your answers. If I put 9 in here, 9 plus 3, sure enough, is 12, and the absolute value of that will be 12. If I put -15 in there, -15 plus 3 is -12. The absolute value of that is still a positive 12. So those are our 2 possible answers. Now, if you notice with both of these, the absolute value on the left is all by itself. There's nothing hanging around outside the absolute value. If you ever have something, a tag-along outside the absolute value, we need to get rid of it before we break it up into our 2 equations. So I need to get rid of the 6 before I can do anything. So I'm going to take and subtract 6 from both sides. When I do that, I still have the absolute value of 2x minus 2, but 10 minus 6 is 4. Now again, you want to ask yourself, what 2 numbers can I put inside of absolute value that would give me 4 as my answer? So I could put 4 in there for absolute value, or inside the absolute value, because the absolute value of 4 would be 4, or I could put -4 in there. So what that means then is I could have 2x minus 2 equaling 4, or I could have 2x minus 2 equaling a -4. Because I can put 4 or -4 inside that absolute value, and inside the absolute value I have 2x minus 2. So 2x minus 2 could equal 4, or the 2x minus 2 could equal -4. Add 2 to both sides. You get 2x equals 6. Divide by 2, and you get x equals 3. Add 2 to both sides on this one. And negative 4 plus 2 equals a negative 2, meaning that you get x equals negative 1. Again, you should be in the habit of checking your answers. Put 3 in here. 2 times 3 is 6. 6 minus 2 is 4. The absolute value of 4 is still 4 plus 6 gives me 10. Put negative 1 in there. 2 times negative 1 is negative 2. Negative 2 minus 2 is still it's negative 4, but the absolute value of negative 4 is a positive 4. And 4 plus 6 gives me 10. So hopefully you're understanding this concept, because there's a few key concepts that we're going to look at in this video. This is the first one. It's just knowing how to solve an absolute value equation. Because knowing this is important to understanding this next part. It's important that you understand this formula, or this theorem. It's called the absolute value square root theorem. And the absolute value square root theorem is given right here. It's that if we have the square root of x squared, that's equal to the absolute value of x. Here's what I mean. In the past, we've looked at problems, or you might have seen problems like this, where x squared equals 81, or and you say that, well, x is going to equal 9 because the square root of 81 is 9. That's true, but it's only partially true. Here's why. In order to get rid of the square, we have to take the square root of both sides. So the square root of 81, yes, that is 9. The square root and the square, yes, they do undo each other, but the absolute value square root theorem tells you they undo each other, but you're left with the absolute value of x. So now, just like we set up above, there's two possible answers here. You could get x equals 9 or x equals negative 9 as your answer. Same thing's true here. If I take the absolute value of if I take the square root of both sides, I'm left with the absolute value of x equals 5. Well, that means our answer is going to be x equals 5 or negative 5. What about a fraction? You still do the same thing. Don't change this to a decimal. We'll leave it the way it is for right now, because you'll see what happens. When I take the square root of x squared, again, that gives me the absolute value of x. The square root of 16 is 4. The square root of 49 is 7. So what you do is you take the square root of the numerator and the denominator, leaving us with 4/7. But again, it's the absolute value of x equals 4/7. So there's two things I could put in there to get my answer. A positive or a negative 4/7. So there's a few ways you could write your answer. As you see here, we could say separately x equals 9 or x equals negative 9. You don't have to repeat the x's if you want to just say x equals 5 or negative 5. Or if you ever have a problem like this where it's the same answer, only one's positive and one's negative, you can write it like this: positive and a negative 4/7. Now let's look at this last example. Again, with this one, I have this x minus 8, but it's inside of this parentheses squared. So to get rid of the square, I'm going to take the square root of both sides. Well, that leaves me with the absolute value of x minus 8 equals 2. And now, it's just like what the problems we were just working on. There's two things I could put inside of there to get 2 as my answer, 2 or negative 2. So that means I could have x minus 8 equals 2, or I could have x equals 8, or x minus 8 equals negative 2. Solve both of these by adding 8, so add 8 to both sides here, and I get 10. Add 8 to both sides, negative 2 plus 8 is 6. And those are our two answers. Again, if we check our answers, 10 minus 8 is 2, and 2 squared sure enough equals 4. 6 minus 8 is a negative 2. Negative 2 when you square it is a positive 4. So that's why we have two possible answers there.